This is the last episode for gas laws. So far, all the gas laws discussed are used to describe a gas sample where change occurs. You have a gas sample, conditions change from one set to a different set of conditions. You use subscripts 1 or 2 to indicate the two different sets of conditions. Then they ask you under the new condition, maybe they ask you for pressure, volume, or temperature. However, for an ideal gas is a gas in which there's no attractions among its particles. Particles in an ideal gas are independent from each other. For an ideal gas, the amount of the gas in moles, the pressure, volume, and temperature has a unique relationship. This relationship is expressed in the ideal gas law. PV equals nRT. The product of pressure and volume equals the number of moles of the gas times by a constant R times by the temperature in Kelvin. R is called ideal gas constant. R could have different values depending on the unit of pressure and volume. However, let's just remember R equals 0.0821. In this case, if you want to use this number for R, make sure the pressure has to be in ATM, the volume has to be in liter. If the question given, the volume is not in liter, the pressure is not in ATM, make sure you convert them to liter and ATM respectively. A practice: an automobile tire at 23 Celsius has an internal volume of 25 filled with air to a total pressure of that. Okay, volume given, pressure given, temperature given, determine the number of moles. All right, so clearly PV equals nRT. How do you know it is ideal gas? It is not one of those we learned earlier. Well, there's no condition changes. They just give you one set of condition, temperature, temperature, volume, pressure, and asking you for the number of moles. None of these numbers changed to a different set of condition. So N equals PV divided by RT. You divide both sides by RT. They cancel it out. So N equals PV RT. P is in ATM, so 2.18. V is in liters, 25.0. R, if P is in ATM, V is in liter, R is 0.0821. Temperature should be in Kelvin, so 23 plus 273, that's 296 Kelvin. All right, you do the calculation, 3 sig figs. The final answer is 2.24 mole gas. Another practice. What is the pressure in a 304-liter tank that contains 5.760 kilos of helium at 25 degrees Celsius? Well, pressure is wanted, volume is given, temperature is given, 25 plus 273 with 298 K. Well, if we use PV equals nRT, V is known, R is a constant, T is given. If we want to solve P, we know we need N, the number of moles. Well, mole is not given. What is given is the mass of helium. When the mass of something is given, how do you get the moles of it? We learned this in chapter 6. From grams to moles, what do you need? Molar mass of helium. Where do you get that? Periodic table. Helium atomic mass 4.003 AMU. So the molar mass of helium is 4.003 grams per mole. So if the mass is given, let's get the mole first. So N mole will equal the mass in grams, 5.670 times by 1,000. Convert kilograms to grams. This is going to be in grams. Then we need to multiply it by a conversion factor so that we can get moles. So mole will be on the top, gram will be at the bottom, 4.003, 1 mole. Well, you can calculate out the final answer for N, and then you plug it here. I would just leave it like this. 5.670 times 1,000 is 5.670 divided by 4.003. I'll just put this number in the formula. Now P equals 5.670 divided by 4.003. That is N multiplied by R multiplied by T divided by V. 304.0 liter. That's good. If you do the calculation, you're going to get P is 114 atm. Dalton's law of partial pressures. Dalton's law talks about a mixture of different gases. If you have different gases in a container, the total pressure will be the sum of the pressure exerted by each individual gas by itself. So there are 3 gases, for example, the pressure from gas 1 is P1, from gas 2 is P2, gas 3 is P3, then the P total is P1 plus P2, P3. The example here tells you if gas A in the container by itself, the pressure is 1. If gas B in the container by itself, the pressure is 3. Gas C itself is 2. Then the total pressure of all 3 gases mixed together will be 1 plus 3 plus 2, which is 6. The total pressure exerted by a mixture of 3 gases, nitrogen, oxygen, water vapor, is 742 millimeter mercury. Okay, P total equals 742 millimeter mercury. The partial pressure of nitrogen and oxygen in the sample are 581, 143, respectively. So P N2 nitrogen is 581 millimeter mercury. PO2 is 143 millimeter mercury. Asking you to get the partial pressure of water. Therefore, P total equals P nitrogen plus P oxygen plus P water vapor. Therefore, P water vapor is going to equal B total minus P nitrogen minus P oxygen, which is 742 minus 581 minus 143, which is 18 millimeter mercury. That's it.